Hey developers! Are your Angular lists slowing down your app? If updating a list using ngFor is causing performance issues, you are in the right place. In this video, I'll show you how to optimize ngFor with best practices and code examples. Let's get started. Let's start with a basic example where we display a list of items using ngFor. Every time we update the list, Angular re-renders the entire list, causing performance issues. So let me explain you the code. In given code snippet is of HTML file and TS file. Let's understand HTML first. ngFor is used to iterate over the items array and display each item's name inside an list tag. Every time items is updated, Angular destroys and re-renders all elements in the list, even if only one item has changed. Now let's understand TS code. The items array initially contains 3 objects. When update list is called, a new item is added to the array. Since Angular doesn't track objects efficiently in ngFor, it re-renders the entire list instead of only appending the new item. This may seem fine, but when you update the list, Angular doesn't just update the new item, it re-renders the entire list. For small lists, this may not be noticeable. For large lists, the unnecessary re-renders can cause UI lag, increased memory usage, and poor user experience. Let's fix that. So let's fix it using trackBy. To prevent unnecessary re-renders, we use the trackBy function, which helps Angular identify which items changed. In the optimized version, we use trackBy to help Angular efficiently manage the list rendering. Let's understand HTML code first. The trackBy function is added to ngFor, helping Angular track items by their unique identifier. This prevents Angular from re-rendering unchanged items, improving performance. Now let's see TS code how trackBy works. It takes 2 parameters. First, index, the position of the item in the list. Second, item, the actual data object. The function returns a unique identifier, item.id, so that Angular knows which items haven't changed. Hope you understand why trackBy improves performance. Before, without trackBy, every time the list updates, Angular destroys and recreates all list elements, even if only one item changes. After, with trackBy, Angular only updates the modified items, leaving the unchanged ones intact. This avoids unnecessary DOM updates and speeds up rendering. For even better performance with large datasets, we can use virtual scrolling, available in Angular Materials CDK. It only renders items visible on screen. This approach drastically improves performance by rendering only what's needed, reducing memory and CPU usage. You can see an example of virtual scrolling on the screen. Let's understand the HTML code first. CDK Virtual Scroll Viewport, this container ensures only visible items are rendered. Item size is equal to 50 specifies the height, in pixels, of each item, helping Angular calculate how many items fit in the viewport. Asterisk virtual for is equal to let item of items, works like ngFor but only renders the visible portion of the list, keeping performance smooth. Now let's understand the TS code. Array.from, length, 10,000, underscore, I, arrow function, id, I, name, item $I. Creates 10,000 items dynamically. Each item has a unique ID and name, example, item 0, item 1, etc. Virtual scrolling ensures only a small fraction of these 10,000 items are rendered at any time, making the UI fast. Hope you understand why we use virtual scrolling. Here are some main points you should remember for your interview about virtual scrolling. 1. It handles large datasets efficiently. 2. It reduces DOM elements, improves rendering speed. 3. It minimizes memory usage. 4. It provides a smooth scrolling experience. Another way to optimize is by using change detection strategy. OnPush. By default, Angular uses a strategy that checks all components for changes. Switching to OnPush makes it update only when inputs change. By default, Angular runs change detection on every event, which can be costly for performance. With OnPush, Angular only checks for changes when the input object reference changes, rather than deeply comparing all properties. This is especially useful when working with immutable data structures or data coming from APIs, as it prevents unnecessary DOM updates and improves rendering efficiency. Now let's see the code example. So this code example demonstrates how to use change detection strategy. OnPush to optimize change detection in Angular components. First, importing required modules. Change detection strategy is imported from Angular's core module. Component is required to define the Angular component. Then defining the component. The selector is set to AppList, meaning this component can be used as AppList in other components. The template URL points to the HTML template where the list is displayed. The crucial part is change detection strategy. OnPush, which tells Angular to skip automatic change detection unless an at input property reference changes and an event is triggered inside the component. Then defining the component class. The items property is marked with at input, meaning it receives data from a parent component. Since OnPush is enabled, Angular only checks for updates when the item's reference changes, avoiding unnecessary re-renders. Now let's see how OnPush change detection optimizes performance. Without OnPush, Angular would check for changes on every event, example, button clicks, keystrokes. With OnPush, Angular only updates the component when the parent component passes a new reference to items, not just modifying its content. And a user event like a button click happens inside the component. Hope you understand it. Now let's see when to use OnPush. When handling large lists to avoid frequent DOM updates. When using immutable data, example, new object references instead of modifying existing arrays. When working with API data where a new array object is fetched each time. Guys, if you want me to create a video on an example demonstrating this with a parent component passing data, please comment down. Optimizing ngFor performance is crucial for smooth applications. Use trackBy to prevent unnecessary re-renders, OnPush for better change detection, and virtual scroll for large datasets. Implement these techniques and watch your Angular app run like a breeze. If you found this video helpful, don't forget to like, subscribe, and comment with your thoughts. See you in the next video.